Let's take a look at a couple examples here and start with example number 1. So a basketball is 4 times as wide as a baseball. Now when we see this, we have to understand that this is a scale factor, but what kind of scale factor is it? What is it dealing with? Is it dealing with dimension, area, or volume? And if we see 4 times as wide, width is always calculated as a length, okay? So we know that this is just going to be K, okay? It's just K. Now, if the baseball has a volume of 12.25 inches cubed, okay, this is going to be one of our volumes. And when we see basketball is 4 times as wide as a baseball, the basketball is being compared. So the basketball is going to be our scale volume, and the baseball is going to be our actual volume. And so this is our actual volume. Now, again, it's all about what we're comparing, and we kind of have to think about the scale as being compared to the original. Okay, so I'm going to go back to an example I used in a previous video, and here's my truck. This is a scale model, or let's say that it is a scale model of an actual truck. That means that we would say that it is how many times smaller, or it's what fraction of the size, okay? So, and that's important to kind of remember. It's, when we talk about it, we're always talking about the scale model as being different in size. So the basketball is 4 times as wide, meaning that it is different by a scale factor of 4. So if this is our actual volume, what is the volume of our basketball? Well, a formula that we have here is scale volume is equal to actual volume times K cubed. Okay, so important to remember that K cubed. And so then we do scale volume is equal to our actual volume, 12.25 inches cubed, and I'm going to put that into brackets, times 4 cubed. Now you'll notice here the cube's on the outside of the brackets, here it's on the inside. Okay, this is as a unit, this is as, it's actually, we have to cube that number. So to find our scale volume, plug it into our calculators here. When we do this, it's 12.25 times 4 cubed. Now you notice I didn't cube the 12.25 because that's already a volume. Don't have to cube it. And we get that it has a volume of 784 inches cubed. Okay, so again, it's way bigger. Okay, it's got a way bigger volume. So think of it as if, imagine what's inside of a baseball would be inside of a basketball, or if we wanted to make a baseball the size of a basketball, it would have to be a whole lot bigger volume-wise. Maybe not so much area-wise or length-wise, but a lot bigger volume-wise. And that's important to be careful for there. So let's try another one here. Okay, Campbell's wants to make a giant soup can that is a scale enlargement of one of the regular size cans. Now, if the regular can has a volume of 350 milliliters and they want to use a scale factor of 10, what is the volume of the bigger can? Well, when we see scale factor, okay, you'll notice that it's not talking about it's how many times bigger the volume is or how many or anything like that. So this is again just K. And this is going to be our actual volume. And again, we have actual volume and we have our K, and we want to find our scale volume because that is times K cubed. So scale volume. And so to find that, we need to, again, multiply. So our scale volume, or the volume of our bigger can, is going to be our actual volume, 350 milliliters. Now, just one thing to watch out for here, milliliters is already a volume, okay, so it's not cubed at all, it's just, we recognize it as a volume. This is actually exactly the same as centimeters cubed. 1 milliliter, 1 centimeter cubed, they're exactly the same. Times 10 cubed. This is going to end up being really big here, okay, because 10 cubed is actually a pretty big number. So we get 350,000 milliliters, or 350 liters. There we go. Okay, there's 1,000 milliliters in a liter. So if we just divide by 1,000, that gives us how many liters. So again, this is how we can find scale volume. Now, so that's kind of going through and determining the volumes based on our scale factor.